Welcome back. In this episode, we'll be focusing on spot wind charts, an essential tool for pilots when it comes to wind forecasting at specific locations. These charts provide detailed wind data for both surface and upper-level winds, helping pilots understand how wind patterns will affect their flight planning. Spot wind charts display wind direction, speed, and gusts for various altitudes, typically at specific flight levels or ground levels. By studying these charts, pilots can identify areas with strong winds, wind shear, and potential turbulence, key factors for flight safety. Let's break down the key elements of a spot wind chart. At the top of the chart, you'll see station identifiers for various airports or locations, such as EGLL for London Heathrow. The chart will show wind direction, in degrees true, followed by wind speed, in knots. If gusts are present, the gust value will be listed after the sustained wind speed. For example, you might see 28015 G 25 kT. This means that the wind is coming from 280 degrees at 15 knots, with gusts up to 25 knots. This data is crucial for pilots when planning takeoff, climb, and approach, as strong gusts can impact aircraft performance. Spot wind charts also provide wind data for different altitudes. The wind at 500 feet will often differ from the wind at 10,000 feet, and understanding these variations is important for turbulence avoidance and optimal flight levels. At lower altitudes, surface winds are influenced by terrain, buildings, and local weather systems, while higher-level winds are often shaped by jet streams and large-scale atmospheric conditions. Another feature of these charts is the inclusion of wind shear information. Wind shear is a rapid change in wind speed or direction over a short distance, and it can lead to turbulent conditions. Spot wind charts often highlight areas of potential wind shear, helping pilots avoid dangerous conditions during takeoff or landing. Let's look at a real-life example, flying from Paris to Amsterdam. By studying the spot wind chart, you notice a wind shift over the North Sea. The lower-level winds are calm, but at higher altitudes, the chart indicates strong westerly winds gusting up to 40 knots. Knowing this in advance allows you to adjust your flight level to avoid turbulence and minimize fuel consumption. In mountainous regions, spot wind charts can provide insights into terrain-induced turbulence. As wind flows over mountains, it can create mountain waves and turbulent air. Spot wind charts help pilots anticipate these conditions and choose higher altitudes or adjust their flight paths to stay in smoother air. In addition to wind speed and direction, spot wind charts also show temperature and pressure at different altitudes. Temperature changes can influence air density, and changes in pressure can affect aircraft performance. This information is critical for flight planning, as it helps pilots calculate true airspeed, altimeter settings, and fuel efficiency. Spot wind charts also show forecasted changes in wind conditions over time. These charts are updated regularly, allowing pilots to stay informed about shifting weather patterns. By comparing the latest spot wind chart with older reports, pilots can track weather trends and adjust their flight plans accordingly. One important aspect of spot wind charts is their role in approach planning. If you're flying into an airport and the spot wind chart shows strong crosswinds, this might affect your landing approach. Pilots use this data to plan for crosswind landings, ensuring they are prepared to land safely with the proper technique. Spot wind charts can also help pilots understand the prevailing winds during long-haul flights. By studying the chart, pilots can determine the best altitudes and routes for avoiding strong headwinds or taking advantage of tailwinds. This can significantly affect flight time and fuel consumption, making the flight more efficient. In addition to forecasting flight paths, spot wind charts help pilots prepare for unexpected weather conditions. For example, if the chart shows strong gusts in the vicinity of the airport, pilots might adjust their approach to avoid turbulence and land more smoothly. In the next episode, we'll explore low-level significant weather charts, SIGWX, which provide crucial data for pilots when flying in low-level airspace. These charts show significant weather phenomena like thunderstorms, turbulence, and precipitation that could affect aircraft operations. Let's recap. Spot wind charts provide detailed wind information at different altitudes. They help pilots plan for takeoff, climb, and landing. Wind shear and turbulence are key factors that pilots watch for. Spot wind charts help pilots adjust their flight paths for smoother and safer operations. See you in Meteorology number 55, Low-Level Significant Weather Chart.